Okay. Okay, so like I said, in the graphing piecewise functions, make sure you pull up Desmos so that you can graph these. Of course, you're going to want to copy it down. So the first one's 1/2 x minus 3, comma, x is less than or equal to 2. And then the next one is negative 2x plus 8, comma, x is greater than 2. That comma is important to let you know when the function ends, and then the rest is just telling you the domain values. And you guys know from domain that that's your possible x values. So when your domain, your x's are less than or equal to 2, you're going to be at this function. When it's greater than 2, you're going to be over at that function. So over in Desmos, still type f of x equals, and your first function was 1/2, so you can do 1 divided by 2, arrow out x minus 3. And you'll see that if I zoom out, it gives you the whole line. So when you're done with those curly brackets right there beside the P, it's shift, there are curly brackets, type the inequality. So you can type x, you can choose down here on the keyboard, there are less than and the equal to here, or in your, if you're just typing it on the keyboard, you can type x, make sure you're in the brackets, less than, which is shift, comma, right? The less than and the equal to. And if you type those two right in a row, it will do the less than or equal to for you. So 2 in the curly bracket. So now your function stops at 2 like it's supposed to. So for piecewise, the second one, f of x equals negative 2x plus 8. And that one is going for x greater than 2. Get rid of your keyboard. So these functions, and we're going to be talking about continuous a lot, but if you have to pick up your pencil at the end of one to go to the other, these are not continuous functions, which means I'm going to zoom in, which means only one of them counts at 2, and it's the or equal to 1. So we have to show that, or you're going to see that. You don't have to do this on yours, but I want you to see it. This function ends at 2, negative 2. So if I put a point at 2, negative 2, that's just a point, right? That is going to be the closed circle because that's the or equal to 1, right? The one that's red, the one that's or equal to, that's a closed dot. And you've done these closed dots before. The other one needs to be an open dot. So to do an open dot, which is at 2, 4, 2, 4, you don't want 2 closed dots. So in your settings, right, if you go to that little wheel, the cogwheel of settings, click on this where you want the open dot and change the style to open. So now I have an open dot there. If I go to, hopefully you guys will be able to see this, but if I go to projector mode, it'll make it a little bit bigger. You can see it. So that's the idea, right? So piecewise function, you have this, and you've done these before, I believe. You have one piece, and it at 2, it's going to change over and become another piece. If those two are in the same spot, I wouldn't need an open and closed dot, and it would be continuous. This is not continuous because it jumps. So what's the value of this function at negative, let's say, over here in these settings, if I take off the minor grids, it'll get rid of any fractional ones. And if I change the steps, or the steps are blank, if I make them both 1, then you actually see. So like if I said, what is the value at negative 4? You'd come down to this function, it's -5. What's the value at 7 for this piecewise function? Well, that's this function at -6. What's the value at 2? Always choose the closed dot. So, and the reason I'm showing you this, when you take a multiple choice quiz, you might have all the functions that look the same, and the only difference is the open and closed dots. So pay close attention. When it's not or equal to, it's open. When it has a little line below it, it's closed. All right, so I'm gonna get my snipping tool. Do a new one. I think you guys, that whole snipping tool, you can see it actually better on, you can see it on the video that I posted. Go back to my paste. All right, so there's my first one. Like I said, these points aren't so important that you do as long as you understand which one would be open and closed when I give you the graph as a multiple choice. All right, so same thing. You got 3x plus 10. When x is less than or equal to 5, the function is -3/5 x minus 8, and the function is greater than -5. So Desmos, clear out everything. F of x equals 3x plus 10, curly brackets, when x is less than or equal to -5. In the curly bracket. So it looks like that one ends at -5, -5, -5, -5, with a closed circle. And since that one's, you can change the color to match the graph with that wheel. The other one was -3/5 x minus 8 when x is greater than 5. Oh, greater than, oops, -5. There you go. So there's no reason to do an open dot there. There's really no reason for this at all. That's a continuous function. There's no question what the value is at -5. It's -5, whichever one you use. When you move these, still try to include the origin in your picture so you can see where it is relative. So again, snip that out. And all this. There we go. Paste it there. Next one. All right, so when it's 3, you can still do the same thing. So the first one is -x minus 6, when x is less than -4. 3x plus 10 from -4 less than or equal to x less than or equal to 0, and -2/3 x plus 10 when x is greater than 0. So 3 parts over in Desmos. I'm going to take this off of projector view for now. So f of x equals -x minus 6 bracket, curly bracket, when x is less than -4. So if you want to go ahead, that's -4, -2. You can see on there where it's ending. So it ends at -4, -2. And since that's not or equal to, that needs to be an open circle. So the next one, f of x equals 3x plus 10, and type it just like it looks, -4 less than or equal to x less than or equal to 0. So it is definitely continuous, right? So there's no reason for that open circle because it continues on. Now, just because it's continuous here doesn't mean the whole graph is continuous. We still need that third part, f of x equals -2 over 3x plus 10 when x is greater than 0. And it is. So the whole thing is continuous. There's your picture. Cut it out. And paste. There you go. All right, so not so bad. When you start getting into the functions that are not just linear, just type them in like we did with that bracket. So if you have x squared plus 10x plus 18, when x is less than -2, 1/2 x plus 1, x is greater than or equal to +2. So right when I see this, like this one ends at -2 and this one begins at +2, there's a big gap in there. So these are not continuous at all. I don't know if I made a mistake and meant to have both of them -2 or not, but the way it's typed, you'll see the big gap in the picture. Clear those out. First one's quadratic, x squared, x equals plus 10x plus 18 when x is less than -2. And then f of x equals 1/2 x plus 1. They wouldn't be continuous anyway if you can see that they're not. But when x is greater than or equal to +2. So there's no doubt because of this gap that those are undefined. Now the first one should end in, so it's ending at -2, +2, -2, 2. To do a point, it's just regular parentheses, but that should be a open circle and green to match the green, right? So the first one ends in an open circle. The second one has the closed circle. And it's at 2, +2. 2, 2. And it's a closed circle. I'm not going to worry about changing the color for that, but you get the idea. If I ask you for the value of this function at like 0 or at 1, -1, it's just undefined. There's nothing going on at all. If I ask you for the value of the function at -5, it's down here at -7. What's the value of the function at 6? Well, at 6, it's 4, right? But in the middle here, it's undefined. Doesn't have anything. So cut out that picture. Make sure you get the minimums in there, get the x-intercepts. So you guys don't see that drop down from Zoom, do you? Okay. Just a couple more real quick. These are all linear. Let's see what goes on. So it is x plus 6 less than -4. It's 1/4 x plus 3 from -4 less than or equal to x less than +4, and 1/2 x plus 5 when x is greater than or equal to 4. So get rid of all that. F of x equals x plus 6, curly bracket, x is less than -4, curly bracket. F of x equals 1/4 x plus 3 from -4 less than or equal to x less than 4. And f of x equals 1/2 x plus 5, x greater than or equal to 4. Okay, so this graph is continuous at the -4. So if I asked you where in the domain is the graph have a spot of continuity, that's the -4. But the whole graph, is this whole graph continuous? No, because you'd have a jump here. So we don't need to label this one, but we do have open and closed circle here. So the green one, which is 4, 4, so at 4, 4, the green one at the +4 is open. It was closed on this side, but it's going to be open on the other end. Closed at the -4, but open at the +4. So I want to open that up. I'll make it green. So that'll give you open circle. And then at the 4, looks like 4, 7, 4, 7. That one is closed. And I can make it match the purple color. I want to make it purple. But there you can see, and again, if you go to projector mode, just makes it bigger. You don't see all the numbers, so that's a little bit trickier. But you can see open and close. So what is the value of this function at 4? The value would be the closed circle at 7, not the open circle. So if I ask you what is f of 4, 7. All right. Take a picture of all that. Go back to your presentation, paste it. All right, so hopefully you guys are hanging in there. One more. So this one has all different kinds. There's a quadratic, negative x plus 8 squared plus 4 when x is less than -5. Absolute value, x plus 3 minus 7. Remember the comma ends the function, and then that -5 is your inequality. -5 less than x less than 1, and then a square root function, square root of x minus 1 minus 3 when x is greater than or equal to 1. Over here, Desmos, f of x equals negative parenthesis x plus 8, shift 6 to get that exponent squared, arrow out, plus 4 when x is less than or equal to negative 5. F of x equals, remember, absolute values. There are absolute value marks on your keyboard above your slash, right above your enter. I'm going to come down here, absolute value, x plus 3, click on the absolute value again to end it, minus 7, curly bracket, negative 5, less than x less than 1. So far, that absolute value function, it is continuous. And then the last function, which is the square root function, f of x equals, again, square root's down here on your keyboard, square root, x minus 1, arrow to get out, minus 3, for x greater than or equal to positive 1. Oh, not parentheses, bracket. All right, so you can see this entire graph is continuous. It never jumps or skips. I don't need to label open or closed because it just is what it is. What's the value at negative 8? Positive 4. What's the value at negative 5? Negative 5. At negative 3, it's negative 7. At positive 1, it's negative 3. At 5, it's negative 1. So you can see all your values looking at the graph. And then the last, cut that one out. Paste it. Okay, so that's the last one. All right, so back at your modules, graphing piecewise functions. When you open that up, there's a link. When you open that link, again, make a copy. Yours will be different than mine. Same type of Google Slides where you just go, use Desmos, graph them, take the picture of it and put it into the document, and then share that when you're done.